All right, so write a conjecture about the pattern. Then use your conjecture to draw the next object in the pattern. So let's just see what's happening here. You can hit pause and try to do this on your own. It's up to you. So we have a triangle in all these shapes, so we know the next pattern should have a triangle because all of these are triangles. Okay, that's number 8. And we have this little ball here, and it starts off in the right corner, then left corner, up. Right corner, left corner, up, right corner. So that means a ball right there in the left corner. All right, let's see what's happening here. Well, we have kind of a curvy thing here and a straight line, a curvy and a straight line, curvy and a straight line, curvy. So we know we're going to have a straight line. So let's see what's happening here. Where do we start? So our first straight line is down in this quadrant. Then it's up here in this opposite quadrant. Then it's back down here in this quadrant. So I'm going to assume that it's going to be up here in this quadrant again. All right, and the last one, we have different shapes, okay? So let's look and see what's different in them. So let's look at any patterns we can find. So here we have 2 triangles, and then we skip every other one, and we have 2 rectangles, and then we have 2 circles, and then we have 2 triangles, okay? That's every other one. So number 9 would probably have 2 rectangles right here. Okay, but that'd be 9. This is every other one. So let's look at the other every other one. So on this one, we have 2 circles here, 2 triangles here, 2 squares here. So circle, triangle, circle, square. No, sorry, my bad. Circle, triangle, then square. So using what we saw from the first one, where it went triangle, square, circle, triangle, repeating, since we're now going circle, triangle, square, we can probably assume that on the right side, the left side, we're going to have 2 circles again, right? I'll be honest, this one took me a while to figure out. So if you look at this pattern here, circle, triangle, circle over square, it repeats 1, 2, 3 right here. Okay? And then this triangle over square repeats 1, 2, 3 right here. This circle over triangle repeats 1, 2, 3 right here. So this circle square repeats 1, 2, 3 right there. And so this right here should repeat 1, 2, 3, circle over square. That was a tough one, honestly. Took me a long time. So inductive reasoning. A conjecture is an unproven statement that is based on observations. All right? A conjecture. You're kind of like saying, I think, based on what I'm seeing, this is what I believe to be true. So you're using inductive reasoning when you find a pattern and then write a conjecture. So your conjecture is kind of like, here's what I think will happen next based on what I've already seen. So that's what we just did. So describe how to sketch the 4th figure in the pattern. So first, in the first figure, we have halves, then fourths, then sixths. So we have 2 parts here, 4 parts here, 6 parts here. So my assumption is the next one will be better drawn than this, 8 parts, first off. And then notice the shading was the upper half, and then the left quadrant here, the left quadrant here. So my conjecture is this is the 4th figure. I could be wrong, but based on what I've seen, that's what I get. Next one. Numbers such as 3, 4, and 5 are called consecutive integers. All right? Just like 5, 6, 7, 11, 12, 13. Make a test conjecture about the sum of any 3 consecutive integers. So let's just do some. 1 plus 2 plus 3 equals 6. 2 plus 3 plus 4, 9. 3 plus 4 plus 5 equals 12. Let's just say 4 plus 5 plus 6 equals 15. 5 plus 6 plus 7 equals 18. So, my conjecture would be the sum of any 3 consecutive numbers adds to be a multiple of 3. Okay? That's my conjecture based on the pattern I'm seeing here. A counterexample. To show that a conjecture is true, you must show that it is true for all cases. You can show that a conjecture is false, however, by finding just one counterexample, right? Just one thing that makes it false. So, conjecture. If you live in Fenton, then you go to Rockwood Summit High. Counterexample. I live in Fenton, but am homeschooled. Or I live in Fenton, but I go to a private high school. Or I live in the city and go to Rockwood Summit High. There are many things that can challenge that. A student makes the following conjecture about the sum of 2 numbers. Find a counterexample to disprove their conjecture. So they say the sum of 2 numbers is always more than the greater number. So they're going, well, 5 plus 7 is 12. And 12 is definitely more than 7. But what if I did negative 10 plus 5? 5 is the bigger number. That's negative 5. Negative 5 is not bigger than 5. Here's my counterexample. Or how about another one, just for the heck of it? 5 plus 0 equals 5. Well, 5 is not greater than my bigger number. It's equal to. Deductive reasoning. That's when you use facts, definitions, accepted properties, and the laws of logic to form a logical argument. This is different from inductive reasoning, which uses specific examples and patterns. So, what conclusion can you make about the product of an even integer and any other integer? Well, if you're, let's just take an even integer, an easy one like 2. All right? If you multiply by 2, okay, you're always going to get an even number. Right? Because you're basically counting by 2s. So 10 times 2 is 20. 50 times 2 is 100. You're basically counting by 2s. So that's just based on what you know about math. Decide whether inductive reasoning or deductive reasoning is used to reach a conclusion. Explain why. So each time Monica kicks the ball up in the air, it returns to the ground. So next time she kicks the ball in the air, it will return to the ground. So this one is inductive. Each time she kicks the ball in the air, it returns to the ground. So we're basing it on a pattern. That makes it inductive. Okay. All reptiles are cold-blooded. Parrots are not cold-blooded. Therefore, Sue's pet parrot is not a reptile. Well, this is deductive reasoning. It's based on facts concerning animals. And biology. All right, exit ticket. Do this on your own and we'll talk about it in class.